So factoring is the huge foundation of 20-1, 30-1. It's huge. So when I'm going through this, I'm not going through it for my top student. I'm not going through all the little strategies for the top student that's like, I don't need this. This is like, I'm going, because the top student will understand what I'm saying, okay? And my average students will understand what I'm saying, and they can turn into my top students, okay? Now, doing this factoring and this algebra, it's like I'm never going to use factoring, okay? And what you don't understand is it is the thought process that goes with factoring that is invaluable, okay? You've got to strategize. I mean, I've got two things that have to multiply to this, and it's a positive, and they add, and that's a negative. And then I got to figure out, first of all, what are the signs, then what are the numbers, and then I've got to go through the steps, and I got to factor it, and I have to be thinking on many different levels. There's things firing up there that you have no idea. And people that are good at that, like people that they're like, you know what, I don't like thinking, I just follow orders and I do it and I come home. That's obviously not this person, okay? A person that is really good at this is really good at solving this is what's going to happen, okay? Now you may sit there and go, you know what, there's nobody can like, this is what's going to happen, okay? I'm going to give you an example. In, like, I can't remember the state, but I was at this conference, and he was telling us that there's this one state, the Department of Corrections, aka prisons, they are able to forecast, because it's huge, like, prisons are big business in the States. They're not like here, where government owns, right? They're privately owned there. And you know, the more prisoners you get, the more money you make, right? Now, you're not out there getting them, so it's not like they're saying, so there's no really conflict there. The courts are sending them there, so it's not like, you know. But they have to forecast every year how many prisoners will be in, because they have to be able to, obviously, because they do get government funding too. Okay, so they got to ask for the government so much money. If they ask for too much, they get in big trouble. If they don't ask for enough, and more prisoners come, comes out of their pocket. And when it's private business, they don't like it coming out of their pocket. And this one state, they are awesome. I mean, they were commended, highly commended, because they could forecast 10 years in advance what their prison population would be. 10 years. Now, there's people on that committee that they got some kind of talent. How do you forecast 10 years? So what do you think they looked at? Come on, be in that job. I need you. I'm going to pay you really well if you can do this, because it saves me millions of dollars. So if I paid you like $500,000 a year and I saved $20 million because of you, you're worth it. So what would you do if you were in that position? You don't want to get fired. What would you do? Yeah? Yeah. You got to look at crime rates. What else? So no one would take this job on? If you, seriously, it's a $500,000 a year position. Would anybody take this job on? Seriously. No one? Just, you would? Okay. What else would you look at then? Yeah? Yeah, because what do you got to look at? Sentence time too, right? Because you're losing prisoners too. They didn't look at any of that. You know what they looked at? Yeah? Yeah? You know what they looked at? You'd be blown away. They looked at the grade 3 literacy rates. You know what literacy rates are? How illiterate the grade 3s are. The more illiterate grade 3s, the more prison cells you need in 10 years. It's weird, eh? This is a true story. I'm not making this up. And that stuff's published. So I bet you the school system had no idea they were using their data even. I mean, anyone can go and get that data. It has to be made public. And you know what? The government commended them, how awesome they were at forecasting. No one had the wisdom to go, what? So if we put more money into education in grade 3 and helped those kids that were illiterate, we would have less criminals. No one did that. But they just commended highly the prison forecasts. Now there's someone that was thinking outside. Do you see why some people do get the jobs? Right? So come on, 10 years ahead of time, he's getting it right. And look at how little work he's actually doing. Find the grade 3 literacy rates. So here's someone who sat down and said, what makes criminals? Not what do criminals do, but what makes them. Isn't that interesting? So there's someone that could think like this. Okay? Because what makes the number 36? That's what we're trying to do. What situations have to be in order for that to happen? Okay? So you may fondly or not so fondly remember these babies right here. Remember them? Yeah? Does it create like a nice warm fuzzy feeling in your stomach? They're algebra tiles. Woo! Can anybody tell me in A what that means? What does that picture mean? Yes. Good. So we got 2x squared plus 7x plus 6. Now, when you were given the algebra tiles, what was the thing you had to do with them? Not a square, a rectangle. You had to make them. Now there was etiquette. There was algae tiles etiquette. What did you have to do first? Yeah. So we know that now. We know that the big ones are x squareds, right? These ones are x's, and these are ones, right? So how would you build a rectangle from these? Okay, well, all you have to do is hit on this button here, and then you got the square, okay? And you see, that's weird, you guys don't have that, okay? So, you got your, so remember you had to put the big squares first, and then you had to use the little rectangles around, right? And then you always filled in the bottom corner with the, and this gave us what you need to always know about factors is when you have length times width, it will give you area. Okay? So this here is x plus 3. Remember you did this, or 2, I should say. That might be a little confusing. Okay? That's x plus 2, right? You just look at the outside edge. X plus 2, and this would be 2x plus 3. See, it's length times width equals area. So that was the whole concept of the algae tiles, right? It's come up with the factors. So, but we got to kind of move on from there, and we've got to learn how to do these ourselves, right? So let's go to right here. Let's go to page 233, and we're going to go right to example 4. And we're going to do, let's do 4A. Now, remember, I'm teaching this so everybody has a plan, okay? You need a plan when you do these. Now these, again, things will be firing in your head, and you got to try to keep all this straight, so have a plan of attack, okay? It's kind of like when I was telling you, remember did I show you how that one clinic, that one volleyball coach, he had broken down how to spike a volleyball or hit a volleyball perfectly through little steps. Did I ever tell you that? How you had the stick, you break the stick in the back of your legs? No? Yeah? And then the bow and arrow, and then, you know how many kids get it right after you show them that? They all get it. But I've seen coaches, they're like, go spike the volleyball, and they're like, okay, so do it like that. And you're like, huh? Like, what? What do you do? You know, if you can have a strategy when you go into this, then everybody can do it. And it's true. I mean, I'm not saying everybody can hit great, but their form, and then they just work on timing. Okay, timing's huge. Well, this, you have a plan, and you got to keep working and practicing and practicing. Okay? You're going to really reveal yourself on your quizzes and your tests if you're not doing this. And then we're going to have a talk. Okay? Because that's what those quizzes do. They help me see how my students are doing all the way through. Now this one here, if you remember the strategy, we're looking for two things that add to give me 17 and multiply to give me negative 18. Now remember, all the way back to Friday, we're going to do what first? Signs. So what are the signs? No. What would be first? Positive. Why? Positive wins. It's going to be the greater magnitude. So I always want to get in the habit of putting it first. Now you can argue and say, well, I get it right all the time, I'm going to do it the other way. But you know what? It seems like the students that do it, the opposite way, then they get to an exam and then they're getting them wrong, right? If you know a defined strategy, I'm always going to put the bigger one first, the winner first. Because if that was a negative 17, I'd have a negative first, and it would be the negative bigger number plus the smaller number. Okay? Even though positive's a bigger number, you know what I'm talking about, just the magnitude, the 17 and the whatever. Okay? So what are my two numbers here? Now what you start doing is just all the factors of 18. (18) and negative 1, yes. Okay? Okay, so that's the first thing. Now, these are different than what I call type 1. What is making them different is the fact that there is this number in the front. And you just can't go to, oh, hey, that's x plus 18, x minus 1. Done, on to the next one. You foil that, you're not going to get this, okay? So, this is 6x squared plus 18x minus 1x minus 3. Now this should be identical to the top. All you did was take this and split it up. You'll always do that. You'll take that number and you'll split it up. Now I have an end to these. These are means to an end, okay? I do have a reason for doing this. And the reason for doing this is now that I have done this, I can get some common factors out. And students always ask, oh, what if I would have put that as negative 1 and 18? Well, first of all, this is the way I would do it because 18 should be first. But if you did it the other way, you should still get the right answer. It's just you don't really have the consistency built in all the time to get good at it. Okay, if you do it one way, and the next time you do it the other way or whatever, then you're kind of not really going to the test with a good plan. Now, what can I take out of that first group? 6x, leaving me with x plus 3, right? And then take out the -1, leaving you with x plus 3. Now, that will always happen if you did it right. And this would be x plus 3, 6x minus 1. Okay? Foil it out or put it in your calculator, you should get the same answer. So even if you look in the book, they won't do it this way. They might do the -1 first and the 18x second and then factor that. So the two signs and then always put the bigger one first. I mean, that's something that just I teach. I've never seen it in a book or whatever, but it does, like I obviously, I think you probably could imagine, I've had a few students in my 20-some years of teaching that don't get factoring. So I give them these steps, and they practice it and practice, and then they can get it in a day, okay? Because I gave them all the little steps, and they love little steps, because, and then those little steps just become routine, and they can do them, and they can go, and they can beat that guy that didn't really study them, and he made a couple of mistakes or whatever, but it's no big deal. I mean, he's okay with that. But it's good to see those students that are like, okay, if I put all this stuff into place, because this course isn't magic. I promise you that. It's not magic at all. Okay? And some students start to actually see that after a while. Okay? Now, let's do B. What would you do on this one? Take out a 5. Again, did you see that? That's 3k squared plus 1k minus 2. Now, because you guys do not have different colors going, you might want to put that as square brackets, because we're going to have to do that question inside the question. You know what happens when you do the question inside the question? You keep going down, down, down. You forget the 5. Okay? So the 5 gets left out. Obviously, if I foiled yours out, and then I wouldn't get the same question, right? 2. Okay, so I'm looking for what two things add to give me 1, multiply to give me -2. So what are the signs? Plus and a negative, good. Because the positive will win. Yep. Yeah, oh yeah. Sorry, yeah, what was I thinking? -6. That's right. I would have figured out when we were doing the next part. We were just doing science, but yeah. Hey, you know what I do sometimes too is now I will put the -6 as my final number, right? And it can't be negative. You know, when I rewrite it, that's one of my bad habits, right? So I know I do that, so I look for it. It's -2 is going to be my last number when I rewrite that. Okay, so what are my two numbers? 3 and -2, right? So then, and I'm going to write it like, if I just had one pen, I would look like this. This would be, oh, sorry, that would be 3k squared plus 3k minus 2k minus 2. And the reason I put the square brackets in there is because I'm doing this next, right? In the first set, I can take out a 3k, leaving me with k plus 1. In the second set, I can take out a -2, leaving me with k plus 1. Now, what's the big question here? But why couldn't you just take out a 2? And I could, but then I wouldn't get a k plus 1 in the brackets. So I'm thinking ahead a bit. Oh yeah, those have to look the same. So I better take out something that they're going to look the same, right? And why do I know that? Because I've done 500 of them. So I know what to look for now, right? And those students that are coming to the quizzes or the tests and they still can't do this, you know, it's pretty obvious, right, that you haven't put in the practice. It's kind of like the old piano recital in front of everybody. I think we can kind of figure out who didn't practice, right? Now, we're going to put the 5 there. Remember, I can take out a k plus 1 out of both of them. If I can't, then I factored wrong. I got to take out something that's in both of them. And then the 3k minus 2 goes there. And you see, the 5 I didn't throw away. If you do, you would never get back to the question, and you would not get the right graph. Okay? Now, what if I have like different, like 2 letters going? Okay? Well, there is no change in what you're doing, except when you put in your middle terms, make sure they add up to negative 5xy. So I'm going to do what 2 things add to give me negative 5, multiply to give me 4. Okay, signs. A negative, negative, right? There's no other argument that would work. Okay, so this is where your thing, where if you find a system that works every single time, that means you've actually figured out the mathematics of it. Okay? That's truly where the mathematics comes, is I know how to do this every time. I just use this system. Okay? Now now you look at the 4. What 2 numbers multiply to give me 4? That when I add them gives me negative 5. Negative 4, negative 1, right? So that would be 2x squared. Now here's where it's weird. Remember, this has got to be this, right? So if I just put minus 4x plus minus 1x, right? Because I've done it, that's the routine, how's that equal negative 5xy? It's not gonna, right? So you just have to that's all you have to do is just be aware. If you're really mechanical about these and you actually don't look at this stuff, then I'm going to catch you. So you really make sure when you're splitting this up, you're splitting it up so it actually equals negative 5xy. Double check that. Yep. Just fell off. Okay, so now I'm going to take out something here and something here. What can I take out of the first set? 2x, leaving me with x minus 2y. Now the next one, negative 1x, or 1y, I should say, or negative y, whatever you want. That would leave me with x minus 2y. And that's always a good feeling when you get that, and you're like, ooh, sweet, got it twice. So then I'm going to take out an x minus 2y, and that is going to leave me with 2x minus y. How would you check that one? Boil it out, see if you get your question back. But what's another way? Okay, remember, I'm asking you to think outside the box. How do you check this? It's weird, right? You guys probably never thought about math. This is where the real math comes. How do I know I got it right?
There will be a grad council meeting in Mrs. Stewart's room at lunch.
Okay, how do I know I got it right? Yeah? Yeah, but what if I did my numbers wrong? What if I accidentally just forgot to write something in there? How can I check it? Anyone got any ways? Calculator won't do it, right? Because there's 2 variables. Can't graph it. Nobody would be able to check this? Any ideas? Someone must have a way to do it. Okay? A good strategy is to pick numbers. Like say make x equal 2 and y equal 3, right? And then just put, a 2 here and a 3 there and a 3 there, or sorry, 2 there and a 3 there. And then come up here and make sure you're putting 2, 2, 3, and a 2 in there. And see, 3. And see if you get the same answer. Okay? That's a way you can check them. You should get the same answer, right? And you pick these numbers. Like, don't pick 87.25 as your answers. I mean, why would you do that to yourself? Okay? Pick nice numbers. Okay? Does that make sense? Again, if you have a system to check it, okay? Like on the last test, many people put that system into place. I mean, I had the most hundreds I've ever had on a test. I had a lot of them. I had people that have, they're new to this 100 game. And I asked some of them, like, how did you bring it up so much, right? And they're just like, I knew a couple ways, sometimes 3 ways to do a question. I knew how to check them, right? So, again, that is what this is all about. Not just getting an answer, but do you know what's right? Now, we're going to talk about perfect square trinomials, okay? So a perfect square trinomial is like p plus q squared. Now, if you were to FOIL that, remember, this is p plus q times p plus q. So let's do the math. That would be p squared plus pq plus pq, right, plus q squared. So the answer is p squared plus 2pq plus q squared. Now, if you had to do, 100 of these tonight, perfect squares, a plus b squared, what would p minus q squared be? What would you see? Because this is a good multiple choice question. It's just going to ask you in words. What is the solution to every perfect square? Okay, now look at the question, look at the answer here. That's all we're doing. Looking at these two. How do you find the first term? Quickly. The first term is the trinomial of the square of the first term of the binomial, right? The last term of the trinomial is the square of the okay, so do you see this? Now, look at how do you get that middle term always? Okay, so I'm asking right about here. Where's my pen? My magic pen. Okay, so I'm looking right here. How can you always get this? Okay, anyway. How do you always get that? That's what I wanted to do. How do you get that? Do you see? What does it say? It says 2pq. So how do you get the middle term always, the trinomial? It is the, what word would go in here? Twice the product of the first and last term. So in other words, the middle term equals 2 times the first times the last. Okay, so P minus Q squared would be P squared and Q squared, right? What would be in the middle? Minus, it would be a minus, right? 2PQ. So remember, if there's a minus, oh, that's a plus there, sorry. If there's a minus here, make sure there's a minus there. If there's a plus there, make sure there's a plus there. This will always be positive. You can't square something and it be a negative. It'll never happen. Maybe on another planet or something. It doesn't happen on this one. Okay, so let's just look down here. Is A perfect square? Now this is what I do. I just use these two first of all, and I build it. So this would be A plus 2 squared. Let's see if this is a perfect square. Because so what I do you see what I square rooted both of these to get these? Square root of A squared and square root of 4, right? To get those. Now, what I want to do is go 2 times A times 2, and this equals 4A. So this indeed will get that. Is B a perfect square? Trinomial. Why not, Logan? Why not? 6 isn't even a perfect square. Good. How about B? Or sorry, C. 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 So you do this. What would go here? 2x. What would go here? No. Minus 9, right? And then what's 2 times 2x times negative 9? So you're going like this. What's the answer to this? It's pretty quiet in here today. Ryan, what would be the answer to that? Two times 2x times negative 9. Negative 36x. So this one checks out, so it works. Okay? Now let's go and do, C. No, B and C. Let's do B and C. What would be the number inside of, actually, let's do A, B, and C. What's the number inside of A? What's that little number in there? To be a perfect square. Now, let's do it. What would the perfect square be? X plus 10. Does that make sense? So therefore, you just go 2 times x times 10 and get 20x, right? So B, what would B be? What would B be? X minus 10 squared, right? Why the minus? Because these two should always be duplicated. And can you write these things on a study sheet? Make sure these are always the same, because you don't want to get caught on a test when it's big marks. And then you just go 2 times x times negative 10, and you get negative 20x. Okay, C. What would be the binomial squared? 5x plus 6. So what's 2 times 5x times 6? 60x, good. Okay, now factor, what would the factor for A be? Okay, again, it's not hard. This comes down here, square root this, square root this. Square root of 49x is 7x. I got to put a minus there, and then I put 1. And double check. 2 times 7x times negative 1 does equal. So it's that ability to know what to do every time. So this is what I do. Okay, I would go like this. And that plus sign, the one that's closest to the x squared. See, the only thing is they've screwed the order up on this one. But I'm going to do it the same way. So what would the first number here be? No. 4. If I switch the order, but this one I'm not going to. 4 plus 5x. And then 4 times 5x is 20x. 20x times 2 is 40x. Okay? How about this one? No, I know a minus sign is going there. What's the first number? 1/3 a minus 3b. And double check. 1/3 a times 3b, that equals, no, that's a negative 3b. That equals, oh, sorry. Yeah. 1a times negative 3b, I'm going to put that in brackets. That's ab. Then multiply that by 2. You do get negative ab, I should say. That does give you that. Okay? So we're doing 1 to 11. A, C, E, G. And you can omit 5 and 8. Got it?